What is a constant? Fundamental constants are unitless constants that define the fundamental laws of physics, and if they were different, then we may not even exist. Over the past few decades, there have been lots of extensive searches for evidence of these variations in fundamental constants. Some of the methods used to investigate this include astrophysical observations of the spectra of distant stars, searches for variation of planetary radii, and moments of inertia, and investigations of orbital evolutions. The speed of light is approximately 3 times 10 to the 8 meters per second. However, it may not always have been this way. There are theories that suggest that this value has increased over time since the early stages of the universe. The gradient of the red line is equal to the speed of light as we know it today. The gradient of the blue line represents how the speed of light may have changed as a result of the rapid expansion of the universe. As you can see, it's a very steep gradient when compared to the red line, which means that this speed of light during this period is much higher than it is today. Unfortunately, there is no hard evidence to verify varying constants, due to the fact that some of these constants may have changed such a long time ago. Theories claiming a change in the speed of light are based on observations of light from many distant quasars. Quasars are often the brightest objects in the universe and allow us to look very far back into the beginnings of the universe by determining their red shift. However, many physicists are skeptical about using this system as there is still so much we don't know about quasars, and this method is highly prone to systematic uncertainties. Furthermore, we often determine the speed of light by evaluating how it propagates through the vacuum, which is controlled by its electric and magnetic properties. However, it has not been considered what would happen if these properties of the vacuum change. If they do change, then the speed of light will change too. Since the vacuum has expanded rapidly during inflation and is constantly rapidly expanding as we speak, it's acceptable to assume that the properties have changed. Does this really make the speed of light constant then? And is our value really that reliable? Einstein had several theories on variable light speeds from 1905 to 1915, but he eventually concluded that light speed is only constant when gravity does not have to be considered. He also said that the velocity of light cannot be regarded as a constant in a constantly changing gravitational field. João Maguire, a professor in theoretical physics at Imperial College London, is a pioneer in varying speeds of light theory. Andreas Albrat and João Maguire proposed that the speed of light could have been up to 3 times 10 to the 30 meters per second in the early universe. The speed of light having a different value could have huge effects in the future. For example, having faster light speeds means having faster possible space travel, which means we are better able to travel to other planets, and searching more planets means a better chance of finding extraterrestrial life. There are even theories as to how this could affect light on a quantum level. A photon is a self-propagating particle. It creates a magnetic field that in turn creates an electric field that then creates a magnetic field. This is a continuous cycle of creating fields. The strength of magnetic fields within an area of space is based on its permeability of the medium that is passing through. Likewise, the strength of an electric field is based on the permittivity of the medium it's passing through. If we could change the permeability and permittivity of the space, then we could manually alter the speed of light. The laws of relativity would not be valid anymore, as relativity states that the speed of light must be constant in all reference frames, and a variable speed of light would mean that every reference frame experiences a different speed of light. On top of this, lots of astronomical observations would be wrong, as most of them are based around using the speed of light as a way of measuring distance. Definitions of distance would all have to be changed, as the light year wouldn't be a fixed number, and the definition for a metre is 1 over 300 million of the distance that light travels in a second, which would now be a variable number. One theory that was used to explain this was the idea that rather than the light moving at a constant speed here, it travels through the ether, an infinite invisible material that fills the universe and doesn't interact with anything. It is said that the light travels at a constant speed through the ether, but the ether doesn't move relative to Earth. The Earth passes through it at a varying speed depending on its orbit around the Sun. Leave a like, smack that subscribe for daily physics, and please give us a high grade for the assignment.